Okay, so this video is on implicit differentiation. We're going to go over a couple things for that. You had a worksheet. You're supposed to finish the other worksheet, which is on implicit, which you only did half of, I think. And then the other worksheet's done, the chain rule one. But I want to show you a couple examples, just a little trickier types. So like, let's say we had this example here. You see how it's like 2xy? What I would do is I would call this the first, and I would call this the second. And now you're utilizing the product rule. So derivative of the first here, and this is with respect to x. So remember that if we're going to take the derivative for x, let's say, right? And what we're interested in is finding is dy dx, right? So let's say we're taking the derivative for x, let's call it that, with respect to x. We want to do our rules anytime we hit an x, but when we hit a y, we have a special snag, right? So here, when we take the derivative of the first, it's 2. Times the second as is y, plus derivative of the second. Well, what's the derivative of y? It's dy dx, right?
Still having problems with your projector?
It has been pretty good, actually.
All right, can I get up there real quick and just blow it out real fast?
Okay, so I said derivative of the first, derivative of the second is dy dx times the first, leave it alone, which is 2x. And that's actually done. We just did that first term. Now when we get to the second term, it's going to be 8y, which you would imagine, but you have to tag on a dy dx. And all this is going to equal 12 because we know the derivative of 12x is just 12. So really what we're trying to do is solve for dy dx. So move some stuff around. So let's see, if we minus the 2y, we now have 2x dy dx. We have plus 8y dy dx equals 12 minus 2y. Now we have to pull the dy dx out, which is 2x plus 8y equals 12 minus 2y. And when we divide through by 2x plus 8y, we have our answer actually, 2x plus 8y. And that's our answer, which is dy dx. We were looking for that, so this is canceled. If we look at the second problem, again, we're trying to find dy dx equals. So when we look at this problem, we have 3 cosine of x. Well, that's an easy one because if we're doing this for x, it's just going to be negative 3 sine of x because the derivative is negative sine. When we get to the second one, we have an issue because we have ln of y. Well, that's always going to be the derivative, which is dy dx, over the original. So that's actually done. You could do 1 over y and then chain rule it times dy dx, or you could just remember the trick. And then here the last one is the 3y. So that's going to be 3 is the derivative, but now we have to tag on the dy dx. So we're just trying to isolate dy dx again. So we have, let's see, negative 3 sine of x. And when we do this, let's see, that's going to be minus 1 over y dy dx. But I'm going to move that to the other side, so I'm going to add it. I'm going to add it to both sides. So it's over here now. We should be able to solve that out for dy dx from there. So factor out the dy dx is going to be negative 3 sine of x over 1 over y plus 3. That would equal your y prime or your dy dx.